Now we're going to look at the 4 levels of measurement. Nominal level data is the lowest level of data. The observations are typically qualitative, so they can only be classified and counted. Data cannot be ordered in any fashion. Examples would be the 6 colors of M&Ms. We would simply classify the candies by color, so there's no natural order. That is, we could report the brown candies first, then the red, then the orange, or any of the colors first. Gender is another example of the nominal level of measurement. We could also count the number of students entering a football game with their student ID and report how many are men and how many are women. We could report either the men or the women first. The next higher level of data is the ordinal level. Ordinal level data is where observations can be classified into some rank or order. The numeric difference in rank only shows the relative position of an observation, but the difference in rank is not meaningful in terms of a numeric measure. For example, if you look at the table on this slide, it lists the student ratings for Professor James Brunner in an Introduction to Finance course. Each student in the class answered the question, overall, how do you rate the instructor in this class? The variable rating illustrates the use of the ordinal scale of measurement. One classification is higher or better than the next one. That is, superior is better than good, good is better than average, and so on. However, we are not able to distinguish the magnitude of the differences between groups. Is the difference between superior and good the same as the difference between poor and inferior? We cannot tell. Interval and ratio level data are data where the difference between two observations can be determined and is meaningful. The only difference between these two levels of data is that an interval level has no natural origin of 0, meaning it cannot take on negative values, where ratio level has a natural origin of 0. The Fahrenheit temperature scale is an example of the interval level of measurement. Suppose the high temperatures on 3 consecutive winter days in Harrisburg are 28, 31, and 20 degrees Fahrenheit. These temperatures can easily be ranked, and we can also determine the difference between the temperatures. This is possible because 1 degree Fahrenheit represents a constant unit of measurement. Equal differences between two temperatures are the same, regardless of their position on the scale. That is, the difference between 10 degrees Fahrenheit and 15 degrees is 5. The difference between 50 and 55 degrees is also 5. It is also important to note that 0 is just a point on the scale. It does not represent the absence of the condition. 0 degrees Fahrenheit does not represent the absence of heat, just that it is cold. Ratio level is the highest level of measurement. Practically all quantitative data is recorded on the ratio level of measurement. You can see the properties listed below. Examples of the ratio scale of measurement include wages, units of production, weight, changes in stock prices, distance between branch offices, and height. What distinguishes ratio from interval scale is that for the ratio scale, the ratio of two numbers is also meaningful. For example, if Jim earns $40,000 per year selling insurance, and Rob earns $80,000 per year selling cars, then Rob earns twice as much as Jim, whereas we cannot say that 40 degrees Fahrenheit is twice as warm as 20 degrees Fahrenheit. Salary, the first example, is ratio scale. Temperature, the second example, is interval scale. In statistical analysis, knowing the level of measurement of data is important. The level of measurement of the data dictates the calculations that can be done to summarize and present the data. It also determines the appropriate statistical tests that should be performed on the data. The chart on this slide summarizes the 4 levels of measurement and identifies their major characteristics. In statistical analysis, it is important for us to identify the level of measurement of data so we can use the appropriate statistical calculation, as well as the statistical test.